Welcome. Today we are going to solve three problems in the topic time response analysis. So coming to the first problem, a causal system having the transfer function h of s equal to 1 by s plus 1 is excited with 5 u of t. The time at which the output reaches 99% of its steady state value is. So coming to the solution, so given is h of s is equal to 1 by s plus 1 and the input r of t is 5 u of t. So if you take Laplace transform, it is 5 by s. So output is given by c of s equal to r of s into h of s. So multiply 5 by s with this h of s. So you will get the output response. So by using the partial fraction method, just simplify this into this equation and taking inverse Laplace transform, you will get the output c of t time response 5 minus 5 e power minus t. So from this equation, it is to be noted that the steady state value is 5. E power minus t is the transient term and 5 is the steady state term. So it is given that in the question the output reaches 99% of its steady state value. So it is nothing but the steady state value into 99%, which will give you, after simplification, 1 minus e power minus t is 0.99. So by simplifying this, you will get the time as 4.605 seconds. So that is the answer. So coming to the next question, if the characteristic equation of a closed loop system is this one, then the system is. So it is a second order system, right? Because the order of the, if you see the power of s, it is 2. So on comparing the standard second order system equation, characteristic equation, we can say 2 psi omega n equal to 3. Okay, so we know that omega n square is 1. So by substituting omega n, we can find that psi is greater than 1 because it is 1.5. So we can say the system is overdamped. So the answer is overdamped. And coming to the next question, the open loop transfer function of unity feedback control system is given by g of s for the peak overshoot of the closed loop system to a unit step input to be 10%. So we have to find the value of k. Yes, the given transfer function is, that is, this is open loop transfer function. Just find the closed loop transfer function that is you know that the closed loop transfer function is g of s by 1 plus g of s h of s, and find the characteristic equation for that. So the characteristic equation will be s square plus 3s plus k, and it is given that the peak overshoot is 10%. That means the peak overshoot m is 0.1. So you know that the formula for the peak overshoot is e power minus pi psi by root of 1 minus I square. So substitute for m, that is our overshoot, peak overshoot, and on simplifying this, you will get the damping ratio psi is 0.59. So you have this characteristic equation, and comparing with the standard second order system characteristic equation, you can get the value of omega n, from which you can derive the, because that this term is nothing but the k. So k is equal to omega n square. So on substituting the omega n, you will get k value as 6.46. So this is the answer. Yes.